Hi everybody, we are in section 2.4, which is solving polynomial equations. We are continuing where we left off yesterday. Our goal is to solve 6x cubed minus 31x squared minus 7x plus 60 equals 0. This particular polynomial is not easily factorable. It is not factorable by grouping. We can't guess and check. Well, we probably could. It would take forever though. But there's a hint given in this one. It says x equals 5 is one of the solutions. Well, if x equals 5 is a solution, I could substitute in x equals 5. If I plugged in x equals 5 into my equation, it would get me a true statement. I would end up with 0 equals 0. And that's great and all, but it doesn't help me solve. Well, let's think about a different thing. If we know x equals 5 is one of the solutions, then probably we came from a factor of x minus 5 equals 0. So x minus 5 is a factor of that original polynomial. That means x minus 5 times something else is going to be 6x cubed minus 31x squared minus 7x plus 60. Our goal is to find what is in those red parentheses. Because once we know what's in those red parentheses, I can solve the rest of the problem. Well, if x minus 5 times those red parentheses is my original polynomial, if these two polynomials multiply to be the original problem, then I can divide 6x cubed minus 31x squared minus 7x plus 60, divide by x minus 5 to figure out what's in the remaining red parentheses. So that's what we're going to do. We're going to use division. Now we can use long division or we can use synthetic division. I particularly like synthetic division, so that's what I'll use. So our goal is to take our original polynomial, which was 6x cubed minus 31x squared minus 7x plus 60, and we're going to divide it by x minus 5. So 5 goes outside. Let's use our synthetic division now. Let's drop down that 6. We multiply 5 times 6 to get 30, add -1, multiply 5 times -1, we get -5, add, that's -12, multiply 5 times -12 is -60, add, and we get 0. Now we should get a remainder of 0. Otherwise, the information that I was given is false. Remember, if something is a factor, when I divide, I should get 0. So now we know that when we divide my original polynomial by x minus 5, our quotient is 6x squared minus x minus 12. Now you can double check it. If you multiply that binomial times that trinomial, you will get back to the original problem. And I could show it for you, but I think you probably trust me. All right, how does that help us? Well, now we know x equals 5 was one of the solutions, right? We had that already. But now we can take our green piece and finish solving. Let's finish solving 6x squared minus x minus 12 equals 0. We can quadratic formula, or we can factor. I'm going to choose to factor it because it is factorable. It factors into 3x plus 4 times 2x minus 3. And if you need help factoring, let me know and I can give you some extra practice problems. All right, finish solving. If 3x plus 4 equals 0, then x equals -4/3. And if 2x minus 3 equals 0, then x equals 2/3. So we have 3 solutions total, one of which was given, and then we found the other 2. Let's try one more like that. All right, before we actually do this next problem, I thought I'd mention something. There are a lot of words we use interchangeably, but I want to be specific with what we're saying. Let's suppose we have a polynomial. If we have an equation, like equals 0, we can say that we have x equals k as a solution, or sometimes solutions are called roots. So saying x equals 5 is a solution to an equation would be an example of that. We could also say that k is a 0 of the function. Saying 5 is a 0 of a function is the same thing as saying that x equals 5 is a solution, which is also the same thing as saying k is an intercept. So like 5 is an x-intercept of the graph, which is also the same thing as saying x minus k is a factor, x minus 5 is a factor. So on that previous problem that we were doing, I could say that x equals 5 is a solution to this equation. I could say x minus 5 is a factor of that polynomial. I could say that x equals 5 is a root. All of these words we use, and we kind of use them interchangeably. So be familiar with the word roots and zeros and solutions and x-intercepts. They all have the same process to find them. All right, that problem that we were going with here. Here we have 2x to the fourth plus 13x cubed plus 19x squared minus 10x minus 24. Okay, and it's f of x equals, we're finding zeros of this function. Well, what do I know? It's giving me a hint. Actually, it's giving me two hints. We know that x minus 1 is one of the factors. We also know that x plus 2 is a factor. I want to figure out what are my other factors, what's left. We can do the same thing we did before. So we're going to begin by dividing by either x equals 1 or x equals negative 2. It doesn't really matter which one you start with. You're going to have to use them both. So I'll start with x equals 1. So I've got my synthetic division. I'm going to put 1 outside. My coefficients of my dividend are 2, 13, 19, negative 10, and negative 24. Drop down that 2. 1 times 2 is 2. Add, we get 15. Multiply, I get 1 times 15 is 15. Add, I get 34. Multiply, I get 34. Add, I get 24. Multiply, I get 24. And add, I get 0. And we said we should get a remainder of 0. So what have I done so far? I'm going to move this down. I've said that I divided my original polynomial by x plus 1, and what I have left is 2x to the third plus 15x squared plus 34x plus 24. That's what I've done so far. Now I'm going to keep going. Notice that x plus 1 is over here, and now I still have to divide by x plus 2. And my goal is to take 2x cubed plus 15x squared plus 34x plus 24, and I'm going to divide that polynomial by x plus 2. Now I've already gotten the coefficients written out, so I'm just going to buddy up over here. I've already got my coefficients written out, so I am going to just line up another line right underneath there. And this time I'm dividing by x plus 2, so I've got negative 2 on the outside. All right, let's do our synthetic division again. Drop down that 2. Multiply, I get negative 4. Add, I get 11. Multiply, I get negative 22. Add, I get 12. Multiply, I get negative 24. And add, I get 0. Okay. Well, again, we knew our remainder was going to be 0. What's important now is we have 2x squared plus 11x plus 12. 2x squared plus 11x plus 12. All right, we're almost there. So now we're going to finish solving. We still have that x minus 1. We still have that x plus 2. Now we can factor 2x squared plus 11x plus 12. Use whatever factoring method you already know how. I know some of you guys guess and check. Some of you guys use the AC method. This factors into 2x plus 3 times x plus 4. So now we're all completely factored. We're going to finish solving for x. We get x equals 1. We get x equals negative 2. We get x equals negative 3 halves. And we get x equals 4. And we have finished. Notice my highest exponent was 4. I got 4 solutions. On the previous problem, my highest exponent was 3. I had 3 solutions. That is called the fundamental theorem of algebra, and I will mention it again probably tomorrow. All right. What happens if we have to solve a polynomial equation with no hints and it's not easily factorable? That's where the rational root theorem comes into play. Now our book calls it the rational zeros theorem, but I think rational root theorem has a nicer ring to it. But they mean the same thing. So basically what it says is if you have a polynomial equation that has a degree greater than 1, so we're not talking about linear equations, x squareds or x cubes or x to the fourths, and it is in standard form. So we have coefficients, and our exponents are in decreasing order. They start with some x to the end, could be x to the fifth or x to the sixth or x to the seventh. There's a coefficient in front of it. And it goes all the way down to a sub 0, which means you have a constant at the end. There are no more x's left at the end when it is written all out in standard form. Okay? The key here is, the thing that I want you to look at is this p over q. Sometimes people call this, oh, the p's over q's. Okay? What it basically says is, if you have rational answers, meaning you have answers that can be written in fraction form, that they will always be in the form of p over q, where p is a factor of the constant, and they're calling it constant coefficient, and q is a factor of the leading coefficient. Now I know this theorem looks kind of confusing, and we're going to walk through it. But what I want you to look at is these two problems that we did already. When we did number 1, notice when I had it in factored form, the x times the 3x times the 2x is what multiplies to be 6x cubed. Where did those numbers end up? They ended up in the denominator of my answers. Notice that negative 5 times 4 times negative 3 multiplies to be 60. Where did that end up? That ended up in the numerator of my answer. So that's why we say that the factors of 60 are my p's, because those end up on the numerator of my answers, and my factors of 6 are on the denominator. Those are my q's. Same thing with the second example we did. Notice if I take x times 2x times x, those all multiply to be 2x to the fourth. Where did those end up? Those ended up on the denominator of my final answer. If I take negative 1 times 2 times 3 times 4, those end up being multiplied to be negative 24. Those end up on the numerator of my answer. Now, when I do all the distribution, that's how I get the rest of the terms. But the important part is that the p's, the bottoms of my fractions, were factors of 24, and my q's were factors of 2. Now, let's try a problem from scratch. We want to solve 2x cubed plus 11x squared minus 7x minus 6. Okay? No hint is given. So what are we doing? We're guessing and checking. Should I just guess any random numbers? Like 7 or 1,000,000? Well, that might take forever. All of the possible rational solutions, all of the possible rational roots will be in the form of p over q. Now, p is going to be factors of 6. So my p's are all of the numbers that go into 6, which are 1, 2, 3, and 6. They could be positive or they could be negative. So I'm going to say plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay? My q's are going to be factors of 2. What are the factors of 2? 1 and 2. So all of the possibilities of p's over q's are all of the numerators, or all of the p's divided by all of the q's. So if I take 1, 2, 3, and 6 and divide by 1, I get 1, 2, 3, and 6. If I take 1, 2, and 3, and 6 and divide by 2, I get a half. I get 2 halves, that's just 1. I get 3 halves, and I get 6 halves, which is just 3, but I've already got those listed. These are all of the possibilities. This here is the list that I'm going to be picking from. I'm going to be picking from this list. So when I'm guessing and checking with my synthetic division, I'm not going to bother checking x equals 7 or x equals 20 because it's not on my list. Now, is there still guessing and checking involved? Yes, absolutely, there's still guessing and checking involved, but at least it helps to have a list to pick from. So we're gonna start guessing, and you might guess, I don't know, I feel like picking 3. Let's pick it. Let's say I'm guessing 3. I list the coefficients, which are 2, 11, -7, and -6. Let's start. I got 2. I multiply, I get 6. I get 17. I multiply, I get 51. I subtract, I add, I get 42. I multiply, I get 126. I add, I get 120. Was x equals 3 a factor? No, it wasn't. It didn't work. How do I know it didn't work? I didn't get a remainder of 0. So x equals 3 is not one of the answers. Let's cross it out. Now, -3 could be an answer, but x equals 3 is not an answer. So we're going to keep guessing and checking. But I know that didn't work. So I'm going to erase. Okay, I know not to try x equals 3. We try a different number. Okay, maybe you try x equals 2, or maybe you try x equals 1. I'll try x equals 1. Okay, I drop down 2. 1 times 2 is 2. I add, I get 13. I multiply, I get 13. I add, I get 6. I multiply by 6, I get 0. Woohoo! I got something to work. Am I excited? Absolutely, I'm excited. Because now the guessing and checking parts are over. I know x equals 1 is one of the solutions. If x equals 1 is a solution, that means a factor of x minus 1 is a factor of the polynomial. What am I left with? I'm left with 2x squared plus 13x plus 6. And notice the original polynomial was equal 0. Now it says solve the remaining equation. Well, I know how to do that. X minus 1 equals 0 gets me x equals 1. 2x squared plus 13x plus 6 equals 0. I can solve by quadratic formula, or I can factor, and this one's factorable. This factors into 2x plus 1 times x plus 6. So I have x equals -1/2 and x equals -6. There are my 3 solutions to this problem. Notice -1/2 was on my list of p's over q's, and so was -6. So if I had started this problem with -6 with synthetic division, it would have worked. And then when I continued solving, the rest of the polynomial would have gotten me the other 2 with x equals 1 and x equals -1/2. So it doesn't matter which one you find first. You just got to find one. Let's try another. Okay. We have 15x to the third plus 38x squared plus 17x plus 2. Right? So we're going to list our p's over q's. Our p's are factors of 2. I have positive or -1 and positive or -2. Our q's are factors of 15, which are 1, 3, 5, and 15. So let's make a big list of p's over q's. If I take 1 and 2 and divide it by 1, I get 1 and 2. If I take 1 and 2 and divide it by 3, I get 1/3 and 2/3. If I take 1 and 2 and divide it by 5, I get 1/5 and 2/5. And if I take 1 and 2 and divide it by 15, I get 1/15 and 2/15. Is that a big list? Sort of. But it's better than just guessing and checking random numbers. All right, here we go. Let's do our synthetic division. My coefficients are 15, 38, 17, and 2. We are picking from our p's over q's list. We're really just guessing and checking. Now, you could start with 1, you can start with 2. I tend not to start with my fractions because I try to do easy math first. I'm going to try -2. Drop down the 15. Multiply, I get -30. Add, I get 8. Multiply, I get -16. Add, I get 1. multiply, I get -2, add, I get 0. Woohoo! It worked. Secret, I knew it ahead of time. All right, but if I didn't, I would just be guessing and checking. All right, x equals -2 is a solution, which means that x plus 2 is a factor. And then the remaining factor is 15x squared plus 8x plus 1 equals 0. Okay, and now we're going to keep solving. X plus 2 times, and we're going to factor 15x squared plus 8x plus 1. It happens to be factorable again. It factors into 3x plus 1 times 5x plus 1. So x equals -2, x equals -1/3, and x equals -1/5. Notice -1/3 and -1/5 were also on our p's over q's list. All right, let's kick it up a notch. Now we're going to solve a 4th degree equation. Okay, so we have 2x to the 4th minus 5x to the 3rd minus 14x squared plus 23x plus 30. Let's list our p's over q's. P's are factors of 30. 1, 2, 3, 5, 6, 15, and 30. Okay. Our q's are factors of 2, which are 1 and 2. So my p's over q's are going to be all of the p's divided by 1, which are 1, 2, 3, 5, 6, 15, and 30. And all of the q's divided, or all of the p's divided by 2, which is 1/2. 2 halves is already on my list. 3 halves. 4 halves is already on my list. 5 halves. 6 halves is already on my list. 15 halves and 30 halves is already on my list. So here's the list that I'm picking from. We hope we're having a lucky day. My coefficients are 2, -5, -14, 23, and 30. And we're really just going to guess. Let's say I start with 1. I drop down 2. 1 times 2 is 2. Add, I get -3. Multiply, I get -3. Add, I get -17. Multiply, I get -17. Add, I get 5. No, I get 6. Multiply, I get 6. Did I end up with a remainder of 0? No. That means x equals 1 was not a solution. We try again. But I know that x equals 1 is not a solution, so I'm going to cross it out. I'm going to say, hey, you didn't work, just so I know not to try it again later. Let's try another number. We could go on to x equals 2, or maybe we want to try an x equals -1. You pick which order you want to go in. I'll try 2. Drop down the 2, I get 2. Multiply 2 times 2, I get 4. Add, get -1. Multiply 2 times -1, I get -2. Add, I get -16. Multiply, I get -32. Add, I get 9. Multiply, I get 18. Add, I get 48. Oh, that's not fun. That didn't work. Try again. I'm struggling through this just like you guys would be. All right, that didn't work. Let's try 3. Start with 2. Multiply, I get 6. Add, I get 1. Multiply, I get 3. Add, I get -11. Multiply, I get -33. Add, I get -10. Multiply, I get -3. Add, and I get 0. Woohoo! So what do I know? I know that x equals 3 is a solution and x minus 3 is a factor. X minus 3 times 2x cubed plus x squared minus 11x minus 10 multiplies to my original polynomial. Well, do we know how to solve 2x to the 3rd plus x squared minus 11x minus 10 equals 0? You can try factoring it. It's actually not factorable by grouping. Guess what we get to do again? We get to do synthetic division again. Yay! So we're going to do some more guessing and checking. Now, something that's cool is you do not need to make a new p's over q's list. What you can do, though, is trim it down. This now, your p is 10. So factors of 10, I'm going to go cross out 30, 15 is not a factor of 10, 6 is not a factor of 10, 3 is not a factor of 10. So I can go cross those out. And my q is 2, which is what it was before, so I can't cross anything out from my q's list. But now I can go through my p's over q's list and take out the possibilities that had 30, 15, 6, and 3 in them. So 15 over 2 is no longer an option. 3 over 2 is no longer an option. 30 is not an option. 15 is not an option. 6 is not an option. 3 is not an option. And that's it. Now, remember before we tried positive 1 and positive 2, those are still not options, so don't go try those again. So now I have a much smaller list to work with. All right, so I'm going to bump up where I left off. What should we try? We tried 1, we tried 2, we tried 3. Should we try 5? Or maybe you want to try a negative number? You get to pick. I'll try 5. All right, I drop down my 2. I multiply, I get 10. I add, I get 11. I multiply, I get 55. I add, I get 44. I multiply, I'm looking at this saying, okay, that's not going to get me a remainder of 0. Let's try again. Maybe I'll try a negative number. Okay, I know not to try 5. All right, what if I try a negative number? Maybe I'll try negative 1. How about negative 1? I bring down my 2. I add, I get negative 2. I multiply, or I add, I get negative 1. I multiply, I get 11. I add, I get negative 10. I multiply, I get 10. I add, I get 0. Woohoo! So that did work. All right. So I'm going to carry down my x minus 3. What else did I get? I had x equals negative 1, so x plus 1 is a factor. Remember, that gets you x equals negative 1. The x minus 3 is a factor, got me x equals 3. And what do I have left? I have 2x squared minus x minus 10. All right, and now I want to solve that. Again, I could factor it, or I can try using quadratic formula. This problem happens to be factorable. It factors into 2x plus 5 times x minus 2. Which is going to get me a solution of x equals negative 5 and another solution of x equals 2. Here are my 4 answers. And again, notice 3, negative 1, negative 5 halves, and 2 were on my list of p's over q's. We'll try one last problem. We have x to the 4th plus 5x cubed plus 11x squared plus 16x plus 12 equals 0. List my p's, which are factors of 12. I have 1, 2, 3, 4, 6, and 12. And my q's are just plus or minus 1. Well, if I take all of my p's and divide them by plus or minus 1, then my p's list is really my p's over q's list. So I have no fractional choices here. Here we go. Guess and check. My coefficients are 1, 5, 11, 16, and 12. Let's guess and check. And I'm going to save you a little time. I've done this problem already. I know that negative 2 is one of the solutions. Okay, we bring down 1. We multiply. I get negative 2. I add. I get 3. I multiply. I get negative 6. I add. I get 5. I multiply, I get negative 10. I add, I get 6. And I multiply, I get negative 12. And I add, and I get 0. Hooray! So my original polynomial factors into x minus 2 times x cubed plus 3x squared plus 5x plus 6. Now, if this problem was factorable, I would go ahead and factor. but it is not factorable, so I'm going to continue with my rational root theorem. So p's over q's. Can I trim any numbers down? Well, now my p is 6 and my q is 1, so I can get rid of some of my p's over q's. 12 is not a factor of 6. 4 is not a factor of 6. And my rest of the list is still there. Now, I could try -1 or I could try 1, but I happen to know that -2 works again. Now, that's not always the case. Just because -2 was a 0 one time, x minus 2 was a factor once, doesn't mean it's a double factor. It doesn't mean it's a factor twice. It just happens to be so for this problem. So 1, -2, 1, -2, add, I get 3, multiply, I get -6, add, I get 0. So I happen to know that was going to be true for this problem. So we carry down our x minus 2 from the first synthetic division. I have another factor of x minus 2 from the second synthetic division. And what is my remaining polynomial? It's x squared plus x minus 3. Nope, plus 3 equals 0. All right, so I got x equals 2. I got x equals 2 again. Do I have to write it twice? No, not really. Okay, and then I'm going to solve x squared plus x plus 3 equals 0. That problem is not factorable. Okay, there are no factors of 3 that add to 1. So what do? Let's try quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have -1 plus or minus the square root of 1 minus 12 is -11 over 2. Simplify that a little bit. I have -1 plus or minus the square root of -11 is I root 11 all over 2. So I have how many answers? Well, we have x equals 2 and x equals 2. Yes, that's only one answer, but it counts for 2 because we got it twice. And then we have -1 plus I root 11 over 2 and -1 minus I root 11 over 2. So we have 4 answers, but some of them are just repeat answers. All right, that's it for today. Your homework is posted on Schoology. Please email me if you have any questions. On Monday, we'll get together and we will summarize everything we learned. Have a nice weekend.